Hello everyone, today we're talking about polar coordinates, section 9.6 in our book. This section is a little bit lengthy, but then we get into the final section next class, and that one will be pretty quick. So make sure you stick with it, and there's quite a bit of material to take down this one. So the first thing we're going to talk about is polar coordinates compared to rectangular coordinates. So polar coordinates are this length r, basically the hypotenuse of our x and y values. And the angle theta tells you just how far that hypotenuse has been rotated around the origin. So that's basically all polar coordinates are. It's a radius with a rotation, the angle. So how to draw polar coordinates. So just for instance, if we had, if we have something with a radius 3, right, that means it's 1, 2, 3 circles out from the origin. And then depending on what the angle may be, right, so if we have a radius, if we have radius of, and these are written radius and theta, and so if we have a radius 3 and a theta 2 pi over 3, right, so that's going to look like that point there. That's going to get us to this point here. Okay, so that's just a little background knowledge of polar coordinates. Now let's go from polar to rectangular coordinates. So they've given me a point in polar coordinates. They want me to go rectangular. So what I have to do is I have to know the equation that x equals r cosine theta and y equals r sine theta. So sticking with the same theme that x is our cosine, y is our sine. We just have this radius in front of our sine and cosine now. So if I go ahead and plug in, I get 5 for my r, and my cosine of theta, 5 pi. Okay, and just like down here, I get 5 for my r sine of 5 pi. So yeah, 5 is times all of that. Okay, so then if you want to find cosine of 5 pi, we got to think about it in exact terms. So if you think about 5 pi, right, this is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So if you think about 5 pi, my x value is going to be -1, my y value is going to be 0. So I can go ahead and plug in for my cosine 5 pi and my sine 5 pi. So I get 5 times -1, because your cosine of 5 pi is -1, and sine of 5 pi is 0. Right, because our y coordinate will be 0 on the x-axis there. So we get a -5 for my x-coordinate and a 0 for my y-coordinate. So that gives us a rectangular coordinate, -5, 0. Let's just verify this. So they gave us the point 5 pi. Right, so it's got a radius of 5 and an angle of 5 pi. And remember, if we start at 0, this is pi, 2 pi, 3 pi, 4 pi. So 5 pi is going to be over here on this line with a radius 5. So 1, 2, 3, 4, 5 circles out. So this coordinate corresponds to this point out here. It has an angle of 5 pi and a radius of 5. So if we compare that to the rectangular coordinate we just found of -5, 0, so 1, 2, 3, 4, you'll see they give you the same point, right? So even if you draw it with polar coordinate or rectangular grid, so polar grid, rectangular grid, you're going to get the same point. Just proves that we can go from polar to rectangular coordinates. One more, let's do this. This one wants to go from rectangular to polar. So to go from rectangular to polar, we need to know that r squared equals x squared plus y squared, and these equations are all on the PowerPoint, and that the tangent of theta, whatever your angle is, y over x. So let's plug in what we know. We don't know r squared, we don't know our radius yet, we're going to solve for it. We do know x is negative radical 6, and we got to square that, and we know y is negative radical 2, and we have to square that. So moving forward, negative radical 6 squared is 6, negative radical 2 squared is 2. So we get r squared equals to 8 is equal to 8, meaning r equals square root 8. So that's the radius. Square root 8, a little bit bigger than 2. So maybe 2.5 is my radius, something like that. And you'll see the same thing. And then tangent of theta is just equal to y over x. And my y is negative radical 2. My x is negative radical 6. So remember, when we're looking for an angle, you have to do the inverse tangent. So I do inverse tangent of, and the negatives cancel, so really just radical 2 over radical 6 equals theta. And when you do that, we can keep this in degree mode because it's easy for us to think degrees and then go back to radians. So when we do this, if your calculator's in degree mode, you get theta is equal to 30 degrees, which we should know by now is pi over 6. Right, so 180 divided by 6, or pi stands for 180 in radian mode, divided by 6 gives you 30 degrees. So that original rectangular ends up with radical 8 for our radius and pi over 6 for our angle. Except for one final thing. Both of these were negative, so we have to take into account what quadrant we're in. So since tangent, right, when we did this, we got a positive 30 degrees. Since they're both negative, we're in the third quadrant. So we need to have a reference angle of pi over 6, meaning that we really have an angle of 7 pi over 6. Right, because we have to have a reference angle of pi over 6, and since both of my x coordinates were negative, I'm in the third quadrant. So this will give us our polar coordinates. Next, let's see, they want us to plot the point, they want us to plot this point, polar coordinates, and then give two other representations of that point. So let me go ahead and get our polar graph. Okay, and so let's go ahead and graph this point. The point is 3 pi over 4, so that means I'm 2 circles out, right? 2 radians out, and 3 pi over 4 is my angle, so I'm over here. So what they want is, they want two representations of this point that have an r less than 0 and an r greater than 0. So they want a positive r and a negative r. So I'll show you what I mean by that. Hopefully we agree that this is this point, and we can get the same point by going around the circle one more time, right? We've practiced that. So the same point as that so we're going to keep the radius positive, so our radius has to stay 2, right? We have to be the same distance away, but what we can change is the angle that we've gone. So I want to end up at the same point, but I'm just going to go around one more time. So let's see, we were here, 3 pi over 4, but I have just gone around, not have I only just gone from here to here. I want to go all the way around and then back to there. So that just means I take and add 2 pi to 3 pi over 8. So this point here would be 2, and then 2 pi would be 4 pi, or 8 pi over 4. So we get 11 pi over 4. So that gives me the same spot, the same coordinate, right? It represents the same spot on my circle, represents the same spot in my polar coordinates, but I just went around one more time. My angle was a little bit larger. So now they want a radius less than 0. So I'm going to tell you what they mean by a negative radius. So when they ask for a negative radius, we still need to end up at that point, but a negative radius flips it over the origin. So what we really need is, since we're looking for this point, like we're looking for this point up here, which is 2 radius away from origin, we really need this point down here, and then the negative r will flip it over. So we know that we want my r to be negative. It has to be 2. We're dealing with 2 units, and I just need to get this angle. So I can have this angle, I can have it a positive or negative angle, so I can go this way and say that that's going to be negative pi over 4. Right? We agreed that would get me to this point, and then the negative r flips it over. So it's got a negative pi over 4, negative r, flips it back up in the second quadrant where we wanted it. Or I could go the positive way and say we still need a negative 2 because we're in the fourth quadrant. We got to flip it over the origin. But this angle would be 7 pi over 4. So those both have negative r values, negative radius values, but they have different angle measures. So the negative flips it over. Next, we want to convert the equation to polar form. So it's in rectangular format. We have x's and y's. We don't have any radius or angles. So to go from rectangular to polar, well, what do I know? I know that x equals r cosine theta. So I can plug that in for x. And I know y equals r sine theta. And these are both squared. So since I'm multiplying, I can distribute the square. I get r squared cosine squared theta minus r squared sine squared theta equals 1. Okay, and then I can pull an r squared out of both terms. So r squared times cosine squared theta minus sine squared theta equals 1. And then I have to get an r by itself, right? All of my polar, they're going to have an r equal to some other value. So for instance, this is a polar equation where you have simply an r equal to some value with our theta. So we have to get r by itself. So to get r by itself, I'm going to have to divide by cosine squared minus sine squared theta. So this will cancel, and I'll be left with r squared is equal to 1 over cosine squared theta minus sine squared theta. And then I just take the square root, so I get r is equal to the square root of all this stuff. And that is my polar equation. I have r, my radius, equal to some value that incorporates my angle. So that's as far as we have to go. Looks pretty nasty, but you don't have to worry about it. We're never going to have to actually graph it from there. Just get to that point where you have r equals some value with my theta, and you've arrived at your polar equation. Finally, we have our polar equation. We want to go back to rectangular coordinates. So what I'm going to want to do here is, since I don't know what individually r is, I could solve for r and get, and just get square root x squared plus y squared, but I don't have an r on this side of the equation. So typically we're going to want to get it into one of these forms that we know. So we're going to multiply both sides by r. When I do that, I get r squared is equal to 6r cosine theta. Well, that's great because I know r squared is equal to x squared plus y squared. And I know r cosine theta is equal to x. So we're typically going to write our rectangular equations equal to 0. Or you can have y on one side. It doesn't matter as long as they're equivalent. So x squared minus 6x plus y squared equals 0. And that is my rectangular form of this polar equation. So go ahead. I've got at least one of each of these examples on the PowerPoint. The answers are at the end. Please try each example. Check your work with the answer at the end. And then we'll talk about it in class tomorrow.